Let's take a look at using exceptions in C#. So here we are in Visual Studio, and we're going to use some demo code called input exceptions. And I'm going to start with the color file. So inside of this file, we have an enumerated type, color, red, orange, and blue. And then we have a static class that contains operations on that enumerated type. We want to convert from a string, in this case color name, into a color value. Presumably someone passes in the string red, with a capital R in this case, and we're going to convert that into the enumeral red. We have to be able to deal with the possibility that what was passed in as a color name is not actually resident in the type. In other words, there is no enumeral that would match that particular string. So we have to decide what to do about that. One possibility is to simply return an arbitrary enumeral. In other words, if I give you a bad string, you're going to give me back red or orange or blue as you see fit. Okay, so let's take a look at how that would work. So I'll create a result, and I will arbitrarily set that result equal to red. And then I will see whether or not the parameter color name can be converted into a numeral of type color. And if the answer to that is yes, then I'll go ahead and do a parse on that string and return that result, and everybody's happy. Okay, so then the question is, what happens if they didn't pass me a proper color name? And the answer to that is here, I had set result to red to begin with, so if I don't execute the code inside of this if statement, then the color will be red, i.e. I will have been returning an arbitrary enumeral. And maybe that's what you want. Maybe that will work. Or as we saw in the exercises, maybe what you want to do is create essentially a blank enumeral, like no color or something like that, to return in this case. But another possibility is that you consider that to be an exceptional situation, or that is to say you throw an exception. So let's look at how that would be done. And that's the next example here. Now for this one, we're going to throw a predefined system exception. And by all means, if you can find a predefined exception that matches your situation, that's a great way to go. So let's look at the code. All right, so the if statement is the same. If things are working, great. But we've added an else portion. And here we're going to create a new exception object. And the class of that exception object will be argument exception. So the syntax is throw new, because we're actually creating a new object. And then there are a number of overloads for this one, but in general, what we want to do is pass a message back. So in other words, whoever called this toColor might throw predefined exception method will receive, rather than the value color, they will receive an exception of class argument exception. So that's predefined version. Another possibility is that you create your own custom exception. As I said, if you can find a predefined exception, that's probably the way to go. But there are times you might want to create your own, or at least see what that code looks like. So in this case, I might throw custom exception method. Again, we'll have the same beginning part, but the else part will, again, throw a new, and in this case, it's a new unknown color exception. So that's a custom color exception that I have defined for this particular project. All right, so before we take a look at how to define your own exception classes, let's take a look at how these things are processed inside of the calling routine. So we go to main, and we see we have a variable of class color, or enum color, and a string. And we'll start off with a situation where the exception is not going to be thrown. In other words, we will start off with a string that actually can be converted into an enumeral of my type. And then I call colorops toColor might return arbitrary enumeral. Now in this case, it won't return an arbitrary enumeral. It will return an enumeral that corresponds with the string color. So then it will just write that out. Okay. Second example is the one that might throw the predefined exception. Again, in this case, this being the happy path successful conversion. It's not going to throw a predefined exception. It's going to simply convert the string BLUE into the enumeral blue. And then thirdly, the one that might throw the custom exception is also going to work properly. So these are all successes. No exceptions are thrown, and obviously no exceptions are being caught. All right, then we move down to the failure situation. And again, there are three possibilities. So here's the value that in fact is not an actual color. And we might return arbitrary numeral, and we will see that no exception is thrown, but the value that we get back does not really correspond so much to DER. It's simply an numeral that whoever wrote two color has decided to return. And if that's acceptable, then, by all means, that's fine. You don't have to necessarily deal with exceptions in this case. However, if you would choose to do that, here is that possibility. Okay, so this one is the failure with the predefined exception. So what we do is we wrap the code, and in this case it's this code right here, we wrap the code that may or may not throw an exception in what's known as a try block. So a try block is a place where you say, well, I don't know if this is going to throw an exception or not. So if it does, you take a certain action, or if it doesn't, you take certain action. Okay, so the first thing I want you to notice is we know that this is going to be a failure because we know that our string cannot be converted into a proper enumeral. All right, so this one not only might throw a predefined exception, but it will throw a predefined exception. So the first thing I want you to note is that if you have code, in this case right here, that throws an exception in your try block, the rest of the try block, in other words, this line right here, the rest of the try block is abandoned. It will not be executed, and control will return to something known as a catch block. All right, so here's a catch block, and as you can see, what I'm doing is I'm catching system.argumentException. In other words, I'm catching the exception thrown by this call, or that could have been thrown by that call. And then I'm using my parameter e, which is of argument exception. In other words, that's the object that was created. And I'm going to print out the message associated with that particular argument exception. And then lastly, the last part of an exception handler is the finally block. And the finally block is always executed regardless of exceptions thrown. So in other words, we were in the try block and we executed this, which caused an exception to be thrown. We then went down to the catch block and we determined that the exception thrown did match the system argument exception. And so we executed this code, and then we're going to execute the finally code. Now, it is possible, let's just imagine that HuName was a legal value. I would have executed the try block by doing this conversion and then writing this line out, and then I would not do anything with that catch block, and I would go directly to finally. Also note that the data type of the exception must match whatever you're saying that it is. In other words, if for some reason up here this code threw an exception that was not of type argument exception, then this catch block would not be executed. And in that case, what would happen is the exception would bubble back up to the top, and we would see that on our console window as an uncaught exception. So in other words, ultimately, if you don't catch the exception, the system will catch the exception for you, and you'll get a message and a stack trace associated with that situation. Next possibility is a custom exception, and as you can see, the code looks exactly the same. I didn't put a console.writeLine after Hu, as we've already talked about, the fact that the try block, the rest of the code in the try block is abandoned if an exception is thrown. So in this case, the exception I want to catch is called unknown color exception. And as you can see, I catch it there and write out the message. Again, if for whatever reason the exception thrown by this code was not of class unknown color exception, then this code would not execute. Notice that we can have multiple catch blocks. So in my example here, we see that I have a switch statement based on a random number that's going to execute one of these three possibilities. Might throw the arbitrary numeral, might throw predefined exception, might throw custom exception. So I don't know which one of these three is going to execute. So the first one, of course, doesn't throw an exception at all, and no catch blocks would be activated, but I would call my finally. If I call the second one, then the catch block that we activated would be the argument exception catch block, and unknown color exception catch block would not be activated at all. And if it's the third one, then unknown color exception catch block would be activated, and the other one, system argument exception, would not be activated at all. And in all cases, we always execute the finally block. So let's run this code and see what comes out. So here we see the three happy paths. So that's the arbitrary one, that's the predefined exception, and that's the custom exception. But again, they were successful, so we don't see any exceptions there. And then we've written out a blank line. And then this is the first failure. In this case, it was an arbitrary. So because the string was not convertible, it just returned red, and we don't know any better, so to speak. And then this is the predefined exception, and that particular block had a finally, and so that's the code that's written as a result of the finally. Notice that the output statement that said this code is never executed was not written here. And then this is the custom exception. And then with our multi-catch block at the very bottom, notice that there's no output statement other than the finally output, which are these two lines right here. In that case, what happened is we called the conversion method that just returns an arbitrary value in the case of bad input. Now we can run this again, and this time we see that with our multi-catch block, we got the argument exception version, and you can see that here because the name of the class is written out. And then we can run this again, and we get the unknown color exception version of the multi-catch block at the bottom of the program. Now let's consider what it would look like to create your own custom exceptions. And so this will be in a file called unknown color exception in the same project. And the syntax is the name of the exception class. Note that it ends with the word exception. By convention, all exception classes include at the end the word exception. It is derived from the class exception. We'll be talking about derivation a little bit later. That basically means that I'm using resources from a pre-existing class to build a new class. And your typical exception has at least 3 constructors, one that takes no parameters and then uses the base class exception constructor to construct the object, one that takes 1 parameter, which is a string, and again uses the base class. And as I said before, we will talk about this sort of construction and base classes in a later lecture. And then one that takes a string message and an exception called inner or inner exception as a second parameter. And what this allows us to do is build up a collection of exceptions, one inside the other, as the exception bubbles up the program. I'm not going to go into more detail about that here, as we won't be using those in this class, but we will see those in later material. And as you can see, I've also added one that takes a string message and a string bad color string, just to give the user a little bit more flexibility in creating their exception messages. So using programmatical checks like if statements, if you can, is generally considered to be better programming than doing a lot of exception handling. So exception handling, sort of as the name implies, should be reserved for exceptional situations. So along those same lines, only throw exceptions on abnormal situations. In other words, things that are not typically expected to happen in the normal, successful, happy path situation. On the other hand, throwing exceptions is better than simply returning error codes as return values or using H results in the case of COM interrupt sort of code. The problem with error codes is the user can ignore them, and then the error propagates through the code and be much more difficult to find, and therefore much more difficult to correct. If you can return null for common errors, that's typically better than exception handling. It's not like an error code exactly or an H result, because the user is essentially forced to deal with it, because if they try to access the object that you returned a null reference for, the program will fail immediately. So if you can use predefined exceptions for the exceptions that you want to throw, that's typically considered to be a better approach. One way to see some of the exceptions that are available to you is to go into the object browser and simply search for exception, because as I said, by convention, exception classes all end with the word exception. And that's exception handling in C#.